name's Kyle Busse, and I'm presenting my designing and implementing of quality STEM instruction. Today's date is Saturday, December 28th, as you can see on screen, 4:20, and I have my microphone set up here and my speaker notes ready to go. So let's begin. So to begin, I want to start off with my personal goals, background, and context. And this is, as I mentioned in my first module, I want to successfully implement my STEM curriculum within my district. This is my first year of doing this, and I am using Project Lead the Way curriculum to do so. And I also want to increase my own personal knowledge of the next gen standards for science and mathematics, because those are both new areas for me in the STEM realm. For my personal background, I got my bachelor's from the Art Institute in Chicago with a major in education, and in Northern recently I got my instructional education master's, and I've been working at the same district, which is 48, for the last 6 years. And the context is this is my first year of doing Project Lead the Way. I went to be trained in robotics and automation, app creators, and the computer science for innovators and makers. And in this unit, in this presentation, I'm going to be discussing the robotics automation section. So for standards and objectives, here is what Project Lead the Way leaves us with, or provided me for our units. So these are the next gen standards, which are included. There's also the ELA standards for Common Core. And lastly, our Math Common Core standards. Again, feel free to pause the movie if you want to look through them. They're pretty straightforward. But what I want to spend more time discussing for standards are ones that are not addressed in Project Lead the Way that I wanted to take a moment to include. And these are also, again, science standards, which is my goal to become more familiar with the contents. And this is specifically including, mainly, including life science standards, because for the first robotics and automation unit for Project Lead the Way, they focus on doing something that includes radioactive material. And in their standards, they include no life science standards. And I want to include more relevant information about what's happened with radioactive material, which includes Chernobyl and the 3 Mile accidents, which are two radioactive explosions I guess I'm a little more familiar with. I know there's the one that happened recently in Japan, but I just wanted to first focus on just these two for my own level of comfort. And like I said, this module does a great job, or the project for Project Lead the Way does a great job of doing earth science standards and engineering standards, and it just misses this one section that I want to help have students examine for their section. Now moving on to my implementation for the first activity ever. My essential questions are as follows. How can automation and robotics be used to protect the Earth's resource and environments, specifically from the radioactive material? And how can the engineering process be applied in daily life? And again, students through this module will help understand how computers and robotics and scientists and engineering, mathematics play an important role in both their modeling and simulation. So day one, it's engage. So I'm using the 5E instruction module as outlined in my resources. And I want students to first define their prior knowledge of what a robot is. And then I'm going to introduce, through Project Lead the Way, they use VEX robotics materials as their form of building. So I'm going to give the students first an introduction of VEX robotics through some YouTube videos and their competition of what VEX does. And first I'm going to have students complete an identification checklist, which comes directly from VEX's website, on first just unboxing, seeing what's inside, seeing what components, what parts, you have pieces that students will have to develop, to build, to construct their robotics, their robot to remove radioactive material. Day 2 is the explore and explain section. So I've completed a simple bot, which is in the image here at the bottom right corner, and it is based essentially a 10-step build for students to put together. And every student will complete this specific unit, which introduces more than half, I'm going to go backwards for a second, of the components of the identification poster. They'll have access to the wheels, to the electronics, to the building, to all the screws and bolts, etc. Just missing a couple gears and other components, which again still gives students enough experience to have again, this is my first year doing this, so they have experience of at least assembling a robot successfully. And then they're going to complete a reflective unit, which is teacher created, an exit slip as well, just so they have a better reflective understanding of why this robot works, how this robot works, and they can explain, as I said, the essentials to building a moving robot. Then moving on to the extend components, this is going to be 3 days, where day 1 I'm going to introduce specifically Chernobyl and the 3 Mile accident, using PBS on their guides online, which I have linked in the resources, and they're going to study the post effects of radioactive explosions. And then end of day 4, all of day 5, and day 6, they're going to develop their bot to manipulate to successfully remove the radioactive material. And the building challenges are, number 1, they have a weight limit. So their robot cannot be 10 pounds. They're limited to building a robot that weighs less than 3 pounds. Like I said, they have about 2.5 days to build. And their robot has to lift at least 2 blocks, which you'll see, which I didn't weigh it, but 2 blocks probably weigh about 4 or 5 grams. And day 7 is the evaluation, and it's a test day. Most excitedly, they get to test their robot. They're going to evaluate the success of their robots, and the success of other robots they see in their class through a formative reflection, and eventually through this took day 8 for some of my students, but through a summative assessment as well. And that will help me, the formative reflection will help me gain and evaluate students' knowledge. And the summative assessment is just the student's ability to determine, or help me determine, the lesson's effectiveness. And moving on to our assessments and accommodations, as I kind of already discussed throughout the 5E day 7s, I am going to be using checklists, which was day 1 of the identification. Exit slips were used commonly. The completed worksheet was through the PBIS on day 4. Physical construction of the prototype and how, if it actually succeeds or not, is a good way to assess. And lastly, my summative assessment as well, which is done day 7 and took some of my students on the 8th day. And to better accommodate, again, this is a group project, so I paired students, or grouped, I guess I could say, partners, in ways that were best able to accommodate all learning needs. And again, for the summative assessment, oral reflections were provided instead of written ones, and for the mathematics component of the summative, scaffolding was helped students during the calculations components. And now for some of the assignment components for this particular project. The anticipated challenges. Number 1, this was, again, I was lucky enough to take this class in the summer, and thank you to all my professors that gave me the extension, because I just completed teaching this unit for my first time in early December. But my anticipated challenge prior to December was, again, my transition from having only an art and tech major to instructing STEAM, which is, all the components to it. Also, my students' ability to transition from my classrooms from only art to tech to STEAM. So, for example, my 8th graders, they've known me since I was in since I've taught them in second grade. So 7 years I've taught them art and tech, art and tech, art and tech, and now this last year for them, uh, I'm now including my art and tech components are being shortened, which they've loved dearly so much, and now including a new subject, which is definitely um, different for their perspective. So their personal, uh, expectations for my class has changed. Students' prior knowledge to radioactive knowledge, I think, I found out was very minimal, uh, very quickly, and just the collaborative element to this is every single thing we do in STEAM, is purely collaborative. It's not really one-on-one. It's students working as a team, and working as a team has many benefits. And while doing something new, working as a team, it is a little slower of a starting progress. So that's what I anticipated, at least. Now, for some of my final reflections, again, I was lucky enough to have taught this for the month of December and put this presentation together, and I have some final reflections that I'm excited to share. Was again, my personal goals, as again stated in Module 1, to increase my knowledge with STEAM, and my ability to first instruct my first project lead the way lesson. The engineering standards to become a lot more familiar with, and the 5E instructional model, again stated in my references, helped me guide, because as much as I love project lead the way, as an artist, I'd like to take a little bit more freedom with my curriculum and take something which is great, use it as a foundation, and apply it to my students in a way that can engage them better instead of using a simple guideline of sorts. And that's, again, I'm looking forward to using the 5E model to better complete or to better utilize additional Project Lead the Way curriculums in my future. And additionally, the outcomes, I was excited to know that all my anticipated challenges weren't as scary as I thought. Students, as you can see in this photo, this was taken by my 6th grade class on December 19th. Or December 18th. It was one of my last days with them prior to winter break, when they were on day 6 on their project and challenging or testing their robots. And in the picture, you could see there's a red and blue and green block. Those are the radioactive materials, and you can see there's 4 bots on their course, and each robot has its own distinct design to it, which again is the creativity which I loved seeing. Engagement levels were totally way higher than I expected. And again, students got to critical think and problem solve, because in Robot 2, there was no instructions, there were no guidelines. They had to work as a team to first design a bot on paper or make a list, which was one of their exit slips, and then take something two-dimensional or abstract in their head and then create it three-dimensional as a team. And that led to authentic learning of students, again, using a bot to remove, in this case, radioactive material, but it could essentially be garbage, or basically like a Roomba, or I think it's called a Roomba, the automatic garbage removing robot. They got to succeed in building a bot. And lastly, references and resources. Super fun slide.